students, I'm Dr. Sumit Majumdar. I'm a pass out of IIT Delhi. I'm from the 2003 batch. Today, we'll be discussing about a very interesting topic that is known as the alternating current. So what is alternating current? You are aware that there is something known as a direct current. All of you, all of us actually have utilized something like batteries, which are dry cells. Dry cells supply to us a constant or a fixed value of current, right? Whereas the current that we receive in our households is actually not a constant value of current. It changes with time. So the changing current that we get in our households is what is known as an alternating current. So this is the chapter that we are going to discuss today. We'll also try to understand how exactly when we apply the alternating current across a resistor, a capacitor, an inductor, how exactly is the variation that takes place. Then we'll also try to understand what is the power or average power that is utilized or power dissipated in the circuit. And then we'll try to understand about something known as resonance in the circuit, which is a very important concept. So stay tuned to listen to all the parts of this particular chapter. So students, today we'll now be starting off with the next chapter, that is alternating current. Why exactly is this chapter important? This chapter is very important for a simple reason, that we talk about everywhere that the current is not a constant. So the current is not really a constant, then what exactly it is? It actually varies with time. So if we have to understand how does the current vary with time, that is what we are going to study in this particular chapter, that is alternating current. So let me now brief you about what all we are going to discuss in this particular chapter. We are going to start off with an introduction wherein we are going to introduce formally as to what exactly is an alternating current. Then we'll go on and understand about how this alternating current, or AC to be short, to be precise, is generated. Further on, we'll go on and discuss about what are the different values of alternating current, the values of the voltages and the current. Then, if we start applying the current, the alternating current to a resistor followed by a capacitor and an inductor, then how exactly it's going to behave. Then we are also going to understand what exactly is the relation between voltage and current for the case of an alternating current. That will be followed up with the introduction or the application of alternating current to a series LCR circuit. I'll also try to give you a brief insight as to what happens if we connect them in parallel. Then we'll be discussing about the phasor diagrams, and we'll also be talking about the resonance that we achieve when we combine the LCR in series and in parallel. Further, we'll also be touching upon the points how exactly is the power dissipated or the power absorbed in an alternating current related to. Okay, so let's start off with the introduction. So as the name itself suggests, we are talking about the introduction to an alternating current. If you can see it here on the board, that we have, this is an alternating current. So here the current actually uses a cycle. So it keeps on circulating, or it basically keeps on going in the form of a wave. So if it moves in the form of a wave, obviously the most obvious choice of an expression is a wave-like equation. So here I'm saying that this is the current. So let's write down the current. So this is I that we have. So since it's an alternating current, so it's basically something which continuously changes in magnitude, and it basically, the magnitude is periodically changing and reversing in the direction. So if I say I is the current, so I is going to be defined as something like I naught, which is the maximum value of current. So here if I look at it, so this is going to be the maximum value of current that I have. So I is going to be equal to I naught into sine omega t. As I mentioned that this keeps on reversing in direction, so obviously there is a time period. So the time period is defined from where the wave starts to where the wave ends. So this represents the time or the time period of it. So that is represented by capital T. So omega is nothing but the angular frequency. So we define omega as 2 pi divided by capital T. So omega into T is 2 pi divided by capital T into the time. Here I naught is nothing but the peak value of alternating current. So current, we define it as I equals to I naught sine omega t. Omega is equals to 2 pi n. N stands for frequency, that is how many times the current is changing its direction and magnitude. So in this first part, we understood how exactly the variation or the motion of a coil with regard to a magnetic field produces a value of EMF. So the EMF that is produced basically opposes the own motion, or opposes the own origin from where exactly the EMF has been produced. So that is the production of an alternating current. Once the alternating current has been produced, then what we do, we understood that if we apply the alternating current across an inductor, or across a resistor, how exactly the variation takes place. We got a glimpse about the phasor diagram as well. So now stay tuned for understanding about if we apply the alternating current across a capacitor, inductor and an RLC circuit, then what is the thing that happens.